let us go back to our lecture previously. So we actually was talking about the permutation groups. And we started before by understanding what we mean by a permutation. So rearrangement lang yan of an element. So say the set 1 to n, if we rearrange it, that is considered a permutation. And what do we have here? Our notation is S sub n. Yes. The number of elements is n factorial, as we have shown. So we provided an example before. The symmetric group S3, S sub 3, that's a set. The set that we are dealing with is composed of 3 elements. That's why the symmetric group S3 has 6 elements. Nakita natin ito. And take note that S3 is not abelian as can be seen in our Cayley table. We also showed that it so happened that because the group of symmetries is different from the dihedral groups. They are of course different groups. However, it so happened that for S3 and D3, they coincide. So yung mismong laman ng S3, actually, nakakorrespond siya sa laman ng dihedral groups. Dihedral groups, we have regular polygons. Tapos ang ginagawa natin sa polygons na ito ay tinatransform natin. Basically, transformation sa geometry is categorized into rotation, either a rotation or a reflection. Although the term that I used here is images, pero parehas lang yon. I think I did not mention this one, but for dihedral groups, if there are n, generalize natin, there are n sides. So, n gonyon, regular polygon siya with n sides. The number of rotations is n, and the number of reflections is also n. So, if n is 3, kagaya ng nandito, 3, ibig sabihin, there are 3 rotations, and then there are 3 reflections. So, nakita natin yung 3 rotations na yan, nandyan, at ito yung 3 na reflections because we are working on D sub 3. And coincidentally, naka-correspond siya 1 by 1 doon sa laman ng S3, the symmetric group. So I am actually discussing this again because I think there was a misconception in our last presentation na hindi yata na-emphasize. So for S3 and D sub 3, nagkataon na parehas sila. So there are 6 elements. Ang D sub 3, there are also 6 elements sa S sub 3. However, we should not conclude that S sub n and D sub n are always the same for any n element of integer na greater than kahit sabihin natin D sub 4, S sub 4 at D sub 4 or S sub 5 at D sub 5. Hindi. Yes, ito yung ibig sabihin ng dihedral groups. Ito ang fourth dihedral group. There are 8 elements as was shown before. And this is the subgroup diagram. So, ang sabi natin kanina, for D sub n, there are n rotations and n reflections. So, ito yung 4 rotations normally denoted by rho sub i's. Rho sub o takes the identity element, and the other rotations, rho sub 1 hanggang sa maubos, nag-stop siya sa D sub 3 kasi square yung pinag-uusapan natin. Nasa D sub 4 tayo. Of course, if we are working with, say, a pentagon, a 5-sided regular polygon, then ang makukuha natin na rotations ay dahil 5, o di 5 din. Ang identity element natin ay ganyan, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, hanggang sa rho sub 4. So that we have 5 rotations in all. Yung nandito, balik tayo sa D sub 4, ay mga reflections. Particularly, mirror images at saka yung images nila if we use the diagonals as the point of reflection. Yan. Pero sa ibang authors kasi reflection lang talaga ang tawag nila sa lahat na yan. And mu sub 1, sub 2, delta 1, delta 2, these are the notations we use for reflections. So for a pentagon ulit, there will be 5 possible reflections. Yung point of reflection natin ay the line joining the vertices in the line that is perpendicular to the sides. Parang yung nangyari dito, ito yung ginamit natin, and then the line that joins the vertices. It happened na naging diagonal. Diagonal pa rin naman yung tawag even for regular pentagons, other polygons, regular polygons like the pentagon. So ang pentagon, ang D sub 5, ang kanyang laman ay 10 elements, 5 rotations and 5 reflections. Ang D sub 4, there are, obviously, on this example, there are 8 elements. Pero ang S sub 4, ilan ba ang laman? S sub 4. Anyone? The symmetric group S sub 4. How many elements do we have for that? Ano na yung formula natin? It's n factorial. Tama ba?
Sir, 24.
Yeah, 24. Yeah. So this is what I want to clarify. Sn and d sub n, S sub n and d sub n coincide only when n is equal to 3. So that's the only time they have the same number of elements. Because S sub n, to compute for the number of elements, to compute for the number of permutations na nandyan kay S sub n, we use n factorial. However, for dihedral groups, d sub n, actually the formula is 2n. So it's really easy to say, to show that they are different. Pagdating natin sa 4, ang S sub 4 ay 24 ang laman at yung D sub 4 ay 8 elements lang. Yeah. Because dihedral groups again are transformations of geometric shapes. Specifically our regular polygons. Pero ito, si S sub 4, ang pinag-uusapan lang natin ay letters or numbers in all possible permutations of it. Actually, ang relationship ng D sub 4 and S sub 4 ngayon is that D sub 4 is a proper subgroup of S4. So, parang permutations pa rin naman yung dating ng mga D sub n. Kaya lang, in terms of the number of elements, normally, most of the time, of course, mas konti yung D sub 4. So, yung 8 na laman ng D sub 4 ay actually laman din lang naman ni S sub 4. But they are not the same. Alright, so that's what I want to clarify. Natapos natin yung orbits. So these are our, again, notation for orbits. And then from orbits, we can actually create our cycles. A cycle is, or a permutation is considered a cycle kapag the rest of the elements here are fixed. Ang ibig sabihin ng fixed kapag 2 yung nasa domain, nakamap sa sarili niya. And then, yung iba forms an orbit. So, dapat isa lang ang orbit para tawaging cycle yon. This is the formal definition of a cycle. The number of elements in that orbit is called the length. Kasi yung orbit yung ginamit sa pag-derive ng cycle na yon. Yes, and when we write cycles, we have our cycle notation, no? For Fraley's cyclic, pero sa ibang authors, cycle notation lang yan. Anyway, let's use Fraley's term, cyclic notation. Yan, para hindi tayo mapagod magsulat ng ganyan. Again, these are just multiplication, disjoint cycles. And we have a very important theorem. Every permutation sigma of a finite set is a product of disjoint cycles. So how do we do that? Actually, dali lang. I-follow lang natin 1, 6, 6, 1. That's, since bumalik siya sa 1, that is a cycle already. So ito, if we are going to use our imagination, this is a permutation that looks like this, except that aside or beside from 1 in 6, the rest of the elements are fixed. Ang ganon. Ganon din kay cycle na 253. The product of two cycles need not to be a cycle. Ayan. So, careful tayo. And, okay, this is now a new concept, transposition, but it's related to those previous slide. What is a transposition? It's very simple. It's a cycle. So, it's a special type of a cycle. Pero ang length niya ay naka-fixed sa 2. A cycle of length 2 is a transposition. Ibig sabihin, sa permutation na yon, lahat ng elements ay naka-fixed except for 2. Alright, this is a very powerful one. A computation shows that. So if you have a cycle, this is a cycle. This is a notation for a cycle. Kasi isang line lang eh. How do we write a cycle as a product of transpositions? Ito daw. A sub 1, i-pair natin sa last element, A sub n. And then, same element, A sub 1, i-pair natin sa next to the last element, kaya A sub n minus 1. Until, i-pair natin kay si A sub 1 kay A sub 2. So, these are transpositions because they are cycles of length 2. Corollary to theorem 2.5. Ang theorem 2.5, it says that all permutations can be expressed as a product of disjoint cycles because transpositions are simply a type of cycle. So, nakaspecify lang kayong kaniyang length na 2. We have a corollary for the theorem. Any permutation of a finite set of at least 2 elements, syempre naman, at least 2 elements, is a product of transpositions, can be expressed as a product of transpositions. Only if the set that we are working with on have at least 2 elements. Halimbawa, we have a permutation expressed as a product of disjoint cycles. So ito yung kaniyang disjoint cycles. Hindi natin nakikita mismo yung original na permutation. We can do that by computing, by multiplying the two of them. Pero hindi natin gagawin yon. How do we express this product of disjoint cycles as a product, this time, of transpositions? Well, we can use this computation. So, of course, this is already a transposition because it has 2 elements. So, we simply copy it. But for the other cycle, we can, that's the cycle that we can break it down to transpositions. So, ano na nga ulit yung sabi ng computation natin sa taas? I-pair natin yung first sa huli, first sa second to the last, and so on so forth. Since tatlo lang naman sila, then our transpositions, the other transpositions are 2, 3. So, it's the middle one, and 2, 5, 2, 5. Of course, we can always verify our answers. So, pwedeng i-multiply natin ulit ang mga ito. So, lagay natin ito sa standard permutation notation form, permutation form. Then, if we multiply, dapat yung original na permutation natin. Alright? Our second example is actually providing us a new information. It's saying that in the symmetric group S sub n is greater than or equal to 2. How do we write the identity permutation of any S sub n? So remember, it's in general, no? Kahit anong subscript pa dyan, kahit gaano kalaki. How do we write the identity permutation? Kasi kunyari 20 yan, S sub 20, ang identity permutation natin alam natin. Parang permutation na 1, 2, 3, 4, 5 hanggang 20, tapos sa baba, ganun din, 1, 2, 3, 4, 5 to 20. What if we're going to write that as a product of transpositions? The answer is dalawa lang because it's the identity permutation. And remember, kahit anong n yan, basta greater than or equal to 2. It is 1, 2, 1, 2. So kahit gaano kalaki ang n. So that leads us to the discussion of what we call even and odd transpositions. Even and odd transpositions. So transposition pa rin naman. When do we say that a permutation is even or odd? We have theorems here and actually a definition yata. Theorem 2.6, it says here that no permutation of S sub n can be expressed both as a product of an even number of transpositions and as a product of an odd number of transposition. Ibig sabihin, hindi pwedeng both. Kung even siya, kung ang isang permutation ay may express as transpositions, and if you count the number of transpositions na nagamit, kung even lang yan, hindi pwedeng minsan even, minsan odd. Well, of course, it's a bit obvious. This theorem is a bit obvious, no? Parang self-explanatory, but this is important for the following definitions kasi. Definition 2.7, no permutation of a finite set is even or odd according to saglit nga. There are typographical errors. A. A permutation of a finite set is even or odd according to whether it can be expressed as a product of an even number of transpositions or the product of an odd number of transpositions. So I think the definition is very simple. How do we know if this is an even or odd transposition? I mean permutation. Although ang binigay ay a permutation expressed as a product of disjoint cycles. It's very easy. Lagay natin siya as a product of transpositions and bilangin natin kung ilang transpositions. 1, 2, 3 in S sub 6 ito. There are 3 is odd, so this permutation is odd. Ito, the next example, if we put it as product of transposition, so we have 1, 8, 1, 6, 1, 4. That's the first 3. And then we do the same for the second cycle, 2, 7, 2, 3, at saka 2, 5. Another 3 transpositions. We have 6 transpositions all in all. Pero it should not be in S6. It should be in S8. There. So it's even. This permutation is even. The identity permutation is of course even. Obviously, 1, 2. There are 2 transpositions. Alternating groups, related siya dito. Related siya sa even and odd. Actually, permutations na lang. Yeah. Dapat permutations yun. Alternating groups. What are alternating groups? If I recall it properly, there are actually 5 important groups na pag-aaralan natin. Yun yung abelian groups natin, dihedral groups, symmetric groups, and ka-level niya ang alternating groups. Yan. What are alternating groups? Saan sila galing? So let's start with theorem 2.7. If n is greater than or equal to 2, then the collection of all even permutations of the set 1 to n forms a subgroup of order n factorial over 2 of the symmetric group S sub n. Remember, n factorial originally is the number of permutations in the symmetric group S sub n. However, if we collect all the even permutations only, and so subset siya, obviously. But because that is closed under permutation multiplication, it becomes a subgroup. So remember, a subset becomes a subgroup if it is closed under the same binary operation na galing sa group. That is how we define subgroup. And you notice that n factorial is originally kung ilan yung total ng permutations na pwede nating or na elements ng S sub n. So, dinivide lang niya ng 2. So, the number of even permutations in S sub n is the number of permutations na nandyan originally divided by 2 lang siya. So, anong ibig sabihin yan? Because for n greater than or equal to 2, the number of even permutation is the same as the number of odd permutations. And both numbers are n factorial over 2. Yeah. So, alternating group is just the same as S sub n. Tinanggal lang natin lahat ng mga permutations na odd. At anong nangyari sa number? Siyempre, nag-decrease. How much ang nabawas? It's half. 50% ang nawala. Kasi ang minintain natin sa S sub n ay even permutations lang. Yung nabuo na group, because of course it's not the same anymore as S sub n, we are calling it alternating groups. And the notation for that is A sub n. And that is what this definition 2.8 is saying. The subgroup of S sub n consisting of even permutations of n letters is the alternating group A sub n of the symmetric group S sub n. Ayan. So, hindi yan. Bakit may ganyan? Ang galing na. I think I haven't provided an example, pero balikan natin si S sub 3. Yun yung meron tayo eh. Dito. Yeah. Alright. Question. If, so we have S sub 3 din. At nakikita natin dito yung mga laman. So, ano yung kukunin natin? If we are to create A sub 3, the alternating group A sub 3 for S sub 3, ito yung A sub 3. There are 6 elements. Alam natin na ang alternating group A sub 3, then, from the theorems that we discussed, is how many? Ilan? Anyone? Yes, what is that? Ano yung sagot?
So, sir, 3?
Yes, 3 lang dapat. Ngayon, piliin natin. So, ang alternating groups ulit, according to our definition is, these are permutations na can be expressed as transpositions. Specifically, there should be even number of transpositions. So, alin sa 6 na yan, yung 3 na laman ng alternating groups natin? Well, the first one is of course the identity, because we know that to express an identity identity permutation of any actually S sub n, it's 1 to 1 2. So that's 1 out of 3 na. Saan pa yung iba? Ano kaya? Saan dyan? Is it,
Sir, you sub 2?
bakit? Ilan ba ang transpositions dyan? I mean, ano yung transpositions?
Sir, yung 3 and 3. Tama ba? Ay, tama ba, sir? Or yung 1, 2, 2, 1?
If we're going to, sige, simulan natin dito sa last. If we express it as a transposition, ano yung transpositions na yan? 1, 3? Tama? Hindi pwedeng 2, 2. Tama ba? Kasi hindi na naman yun cycle. So 1, 3 lang actually. What is 1, 3? So how many? Transpositions do we have? There's only one. Tama? Ganun din actually dito. 1, 2. That's actually the cycle. The original cycle is 1, 2. Since 1, 2 lang, edi transposition na rin yun. Wala nang iba. 1, 1. Siyempre, hindi na pwede. 2, 3. 2, 3 lang dito. So, isa pa rin dito. How about row sub 1? Ang cycle natin ay 1, 2, 3. If we're going to write that cycle 1, 2, 3 as transpositions, we have 1, 3 at saka 1, 2. So there are two transpositions even. So one element of the alternating group is this one. And perhaps, of course, obviously, ito yung isa. Kasi ang cycle natin dito ay 1, 3, 2. 1, 3, 2. So, two transpositions pa rin. So, ang alternating group natin ay it's the set containing P sub O, P sub 1, or rho sub O, rho sub 1, rho sub 2. So, ito yung add permutations na tinanggal natin para mabuo natin yung A sub 3, the alternating group for S3. Sa S sub 4, so there should be 4. And if our observation is applicable dito, ang alternating groups natin ay yung mga rotations. So of course, this is 1, 2, 1, 2. Automatic yan nakasama sa alternating group. And plus, it's a group. Kailangan may identity. Kailangan i-carry niya yung identity. If we check, ano yung cycle na mabubuo natin dito? Ang first cycle ay 1, 2, 3, 4. 1, 2, 3, 4. Nasusundan ba? Paano kaya? I-encode natin. Saglit lang. I'll copy this in Word. Can you see the Word file? Ikita ba?
Yes, sir.
Sige, i-compute na nga natin. First, isulat natin as a product of disjoint cycles, and then transposition. Bakit natin gagawin yon? Para alam natin kung there are even number of transposition or odd number of transposition. So, sige. Let's start with P sub O. Row yan. This is the identity element. So, we know that this is 1, 2, 1, 2. Yeah. So, obviously, this is even. Even. How about P sub 1? Yeah, diretso na tayo. Nakikita natin dito yung row sub 1. So, the cycle is 1, 2, tapos 2 is mapped to 3, 3 is mapped to 4, 4 is mapped to 1. So, isang cycle lang. Actually, isang cycle lang talaga yan. Syempre, wala yung 1 doon. Tapos na. If we're going to write it as a transpositions, product of transposition, then we have 1, 4, 1, 3, and 1, 2. Ayan, so add pala siya. Hindi ganun parehas yung observation natin kanina. If we have the next rotation, P sub 2. Ang cycle natin ay 1, 3, 1, 3, 3 is mapped to 1. So, that ends one cycle. Another cycle, we start from 2, and 2 is mapped to 4. 4 is again mapped to 2. Bumalik siya. So, do we need to write it as a product of transpositions? No, because they are transpositions na. Agad-agad. So, even number of ito add number of transpositions. So, kailangan talaga nating i-compute. That's the next one is row sub 3. As a cycle, we have 1 mapped to 4, and 4 is mapped to 3, and 3 is mapped to 2. And of course, balik siya sa 1. 2 is mapped to 1. Hindi siya transposition. It's a cycle of length 4. So we need to break it down. So how do we do that? 1, 2, 1, 3, at saka 1. Again, add. How about ito, yung yung ibang laman. For example, V sub 1. Cycle. Will you please tell me? Ako na lang ang mag-encode.
One, two,
1, 2, 3, 4.
1, paano?
2.
Ilang cycles muna? How many cycles?
Sir, dalawa.
Dalawa.
2 po, sir.
And then, the second cycle starts at
3, 4.
3.
3.
So, transposition na sila agad. Tama ba?
Yes.
Yes, sir.
Even. Pangalawa, V sub 2. Kindly tell us the cycle.
Sir, 1, 4, 2, 3.
Is that a single cycle only?
Sir, 2, 3 pa po. Yes, sir.
Ganyan?
Hindi, sir. Another one po.
Another. How many cycles?
2, sir.
So the first cycle is,
1, 4 po, sir.
and then the other,
2, 3 po.
3. So, even siya. Well, nakaapat na tayo. But let's show na talagang, kasi meron tayong theorem, di ba, na hati yung number of even and odd. So, dapat yung ito, odd sila. There are odd number of transpositions. Let's verify that. So, we do it for delta sub 1. Cycle, please tell us the cycles.
Sir, 1 lang. 1, 3.
1, 3. Yes, kasi naka-fix na ang 2 at saka 4. And then, how about the other one? Delta 2.
2, 4, sir.
2. So, add ba yan or even? Even.
Add, sir.
Add. Tama. So, anong alternating group natin dito? A sub 4, di ba? Ang terminology natin, notation natin. Ang laman ng alternating group natin ay, of course, it's a group. Regardless kung anong klaseng group yan, we should carry the identity element. Permutation ito. At the same time, dahil even din siya, of course, dapat mag-match. And row sub 2, what else? Kasama din ang mu sub 1 at saka mu sub there. Alternating groups. Yun lang actually yung ibig sabihin ng alternating groups. Even siya. Even. Of course, alam natin yung alternating groups. Alam natin yung kung sino yung mga add, kung ano yung naiwan dyan. I think that's the last slide for our presentation today. Do you have questions?
Opo.
Okay lang? Sige. I hope you are starting now to read, no, to prepare your presentations. Although, ang susunod natin, there are 2 major topics na tatapusin ko. Cosets and the theorem of Lagrange in normal subgroups. Medyo mahaba-haba pa naman to. I might finish this one Friday. So, the first presenter must be ready by Monday. So, kahit mag-extend ako ng Monday, di Tuesday, gano'n. Pero baka matapos ako ng Friday. Sino na ulit yung first presenter natin?